We are here on a gloomy, cold, for all you fall loving freaks. I hope you enjoy what you got now because now it's cold and dreary, and we can all feel the hints of seasonal depression starting to slip in. If you haven't done so yet, don't forget hit like, hit subscribe, hit the bell. All right, so here's the deal exponential functions. There is a long, convoluted math nerd way to say this, but basically, this is it. If it's an equation, x is the exponent. Not x has an exponent, but x is the exponent. X is the little, small, Yoda looking character in the backpack that Luke Skywalker is running through Dagobah with. Okay. Now, the next thing that you need to know is that the y values change by multiplying. Okay. We're going to look at this later this year. And um, we'll have to define with is one either linear, exponential, or quadratic. So, all right. So let's look at this here. All right. How do I go from 3 to 9 in number one? Yeah, I multiply by 3. What about 9 to 27? Multiply by 3. Multiply by 3. I get to the next y value by multiplying. So guess what? This is an exponential. See, that goes along with that blue thing. Y change. Yeah. That was a weird sound. I'm not going to ask what it was. Could have been an underleg noise, but we're going to keep going. Okay. How do we go to from -1 to 1? Yep, plus 2. 1 to 3. 3 to 5. All right. So this is a plus 2. So this one is actually a linear. Okay. This is a linear because the y's changed by adding. Okay. I know everybody's tired. Everybody kind of, you want to be at home in your cocoon of like fleece blankets and stuff wrapped up, looking at the back of your eyelids, right? Me, on the other hand, I'd rather be outside. I know I'm weird. Just no, I'd be layered. Oh, trust me, I've got the gear, dude. I can. All right, number three. If we look closely on number three, where's the x in number three? Yeah, on 7, and it's like an exponent, right? Because it's little. It looks like it's getting a piggyback ride. So this is exponential. Why? Well, let's see. Definition. X is the exponent. That's. I mean, that's the easiest way to find it. If x is the exponent. Okay. All right. What about number 4? All right. So yes, there is an exponent, but it's on the what? Yeah, it's on the x. X is not exponent. No, don't worry. Every time I've taught this, everybody's like, "Oh, that's exponential." X is not the exponent. It has the exponent. This is actually a cubic. So this is we're going to say this one's neither. I can't spell. And yes, I had to scroll over to see how to spell it, so I wrote it right. Yep. Number 5. Yeah, this is linear. We should know this because we have actually graphed many linear equations. All right. And number 6, where's X? Yeah, it's on the point. It's piggyback. Look, it's like the little kid that's like on the shoulders of the parent. Y'all seen that? Well, sometimes. My favorite is when I see people out in public that's got a little one up on their shoulders and they're like eating something and it's like all over the parent. That's so great. It's so funny. All right, so this is an exponential. All right, so remember two ways: if x is the exponent, or if the y is changed by multiplying each time. Okay. Hmm. All right. So let's move on down. Now, evaluating x for a given value. All right. So for number 7, we're going to say this is 5 to the 4th power. So on the calculator, most of them, doesn't matter which model you have, it should be the same. We're going to say 5, and then we're going to remember it's the raise the roof button, that little caret key right there. Raise the roof. 4, and we get 625. Okay. Now this dot, remember the big dot in the middle, like a big belly button, means multiply. So when we type this in, we're going to do 3 parentheses 4 parentheses. Same thing, raise the roof, -3. Okay. You should get 3 over 64. Now, what's funny is in years past, I have taught this after we've learned, negative exponents. Basically, this is the same thing as saying 3 over 4 to the third, because remember, if it's negative, we put it in the basement, right? 3 to the 4 times 4 times 4, just 3 to the 64th. That's the long way to do it, or that's the way to explain it other than using the calculator. Some people, they need a little bit more foundation to go on other than the calculator says so, because everybody's like, the calculator gave me a wrong answer. Well, you know what? Spoons make me fat. So, and then 8, 0.7 to the third, 8, 0.7 to the third. Okay, 2.744. Now, it would make sense to have an answer that is a decimal because we had a decimal in the problem. Okay, that's some things to kind of look at as you're doing these. Okay, does it have a decimal in the problem? All right, is everybody good with 7 through 9? Anybody need a little bit more time? For those that are taking notes, was that a hiccup or something? What was? Oh, that was a no. That was a no. I know a guy that when he hiccups, it sounds like a donkey. He goes, oh, that's how he hiccups. So I was like, so funny because we would be out in public somewhere, like at a dinner, and he would do that. I was like, oh, you don't like the microscopic Chihuahua sneezes? All right. So 30 flower beetles are left undisturbed in a warehouse bin. Okay. The beetle population doubles each week. Okay. Okay. We're going to learn a little bit more about this word doubles and stuff like that and how to pick out stuff. But I'm glad that it is. It helps you that it's in bold. Okay. So when we're doing this one, it actually gives us the equation. Okay. So X number of weeks after 8 weeks. So we would actually say 30. We start with 30. They double every week and 8 weeks. So after 8 weeks, you have 7,680 flower beetles. Now, some of y'all might think that's not really a big deal, but if you've ever bought certain flour before and all of a sudden found out that it had bugs in it, that's not a good deal. That's actually happened to us a couple times. And it's not like we're buying our flour from like, some guy on the side of the road in a pickup truck. We actually went to a store. I know that some of y'all think because of where I live, that's how we get stuff. We have to take the horses in the town and go to the general store. All right. So that's number 10. All right, number 11. Okay. Evaluate over the domain, this right here. So basically, we're going to have this problem. Eh. Now, I'm just writing it out. Some people won't have to do this. You'll just use your calculator all the way. There's 5 of them. Okay, so we're going to have it to the -1. -1, 0, 1, 2, and 3. All right. So 128 parentheses 1 over 2 to the -1. It's actually 256. All right. Anything to the 0 power is what? 1. Yes. Remember, test on that coming Friday. Good thing we'll have a couple of days of review. All right. 1. So this ends up being 128 times 1, which is 128. Okay. So 128, 1 over 2 to the 1. Okay, should be half of 128, which is 64. All right. 1 over 2 squared should get 32. 128 over 1 half to the third should be 16. Now, if we look at this, look at these range, these y values we got, are they going up or going down? They're going down. Okay. They're actually going down by a factor of half. Okay, because if we were to multiply 256, or 128 by half, we get 64. Okay, remember, multiplying by a fraction is the same thing as dividing. Yeah, 128 divided by 2 is 64. 64 divided by 2 is 30. That should be 32, not 36. Who let me write 36? You're kicked off the island. What if classes were like that, like high school classes were like that, where you know people got voted off the island, like Survivor or something like that, like some of these reality show games. That would be hilarious. I would love to do that. Hey, Snacks, what does the skeleton say when they're mad at somebody? Yes, I've got a bone to pick with you. All right. So is everybody good with number 11? Anybody need more time? Need a little bit more time? Yeah, okay. Yeah, there's a lot to write down. There's a lot going on. There's a whole bunch going on. Good? Okay, we're good. All right. So, an exponential function, you may want to write this down, can model growth or decay of an initial amount. Okay? Growth or decay of an initial amount. All right. This is how people do the carbon dating, on, like, hey, it's this old, or for nuclear decay and things like that. Okay, A is called our initial amount. This is like what we had earlier with the flower beetles. We started with 30. The initial amount must be more than 1. All right. B is called the rate. B must be greater than 1 for exponential growth, and between 0 and 1 for exponential decay. Okay. Yawning. I don't understand that, because my coffee has my heart rate racing, but yet I am still sleepy. Mm, really good flavors today in coffee. Got a little maple, got a little caramel macchiato mixed all in it. Yeah, I like buying different coffee grounds, mix them all together in my big, you know, Maxwell House plastic thing, shaking them up. All right, so everybody got these words in? All right. So let's look at this. Identify the initial amount, the growth factor, or decay factor. Okay, so we're going to identify all our initial amounts in blue. Bless you. And we're all going to do them as a of 0. So I want to put a of 0, or actually, let's just do a. All right. So for number 12, what is our a for number 12? 3. Okay. And for number 13, 5. And for this, 1,200. Okay. Thought there was another one on here. Oh well. And looks like I copied something twice, so these are all going to be growth. That's great. So our B, okay. Well, remember our B's are the one that have the x to the power, so this should be 2, 1.03, and 1.03 because Mr. Jeffries accidentally copied and pasted the wrong thing. Okay. Now, if we would have something like, somebody give me a number that's bigger than 1. It could, huh? 2, okay. Like if we had something 2.75 to the x power. Well, our a would be 2. Our b would be 0.75, and this one would be decay because our b is between 0 and 1. I meant to have that on one of these, but apparently I messed it up yesterday. Can't have nothing. Look, I'm just surprised I actually made it through the whole day yesterday. All these three right here, all these are growth because our b is greater than 1, and I can't spell growth. Yeah, yeah. If we go back up here, if our rate, if b is greater than 1, exponential growth, b is between 0 and 1 for exponential decay. All right. So, in a single elimination tournament starting with 128 teams, what would this be? What would you think our 128 teams be? Yeah, that is our A. That's our initial amount. So, we're going to put 128 right here because that's what we are doing. Half of the remaining teams are eliminated in each round. So, look, it's bolded and underlined. Okay. Oh my goodness. Okay. This is actually a decay factor. We could say 1 over 2, or you could actually say 0.5. There's no requirements on that because it doesn't say to write as either a fraction or a decimal, does it? No. So if it doesn't specify, everything is okay. All right. Using parts A and B, write the function. Now remember, our function looks like this. And you can do parentheses. I'd rather you do parentheses because some of y'all that try to do the dots, like this. When it's handwritten, sometimes it's not great. Parentheses are easy. All right, so we're writing this. So let's do. So this would be y equals 128, 0.5 to the x power. Okay. Now, how many teams are left after 5 rounds? Well, we take what we just did and we raise it to the 5th power. And we put it in our calculator. If you can do 128 times zero point 0.5 to the 5th power in your head, you're probably in the wrong class. Believe it or not, we're left with 4. Okay. Now, is there any example that we have like this in the real world where there's a big tournament and after each round there's only half of them left? Huh? The Purge? No. Close. It is basketball. March Madness, the NCAA tournament, except they start with 64 teams. Yeah. Yeah, college basketball. The For me, I like college sports more than I do professional, just because they seem to play a little bit harder. That's just a me thing. Yeah. All right. Believe it or not, guess what? Huh? That is the end of our lesson. Short, sweet, to the point. No muff, no fluff, and all kinds of good stuff. All right. So we actually did have a couple of likes on our recent videos because people are like, "Hey, I might have been not have been paying attention that day. I can go back and look at it." Crazy, crazy. Don't forget, hit like, hit subscribe, hit the bell, leave a nice comment like, "Wow, Mr. Jeffries, your beard does not look as gray as it should," or "Wow, your forehead is growing exponentially." That would be funny if you actually used a math term in your comment. Like, the funniness of your jokes would be an exponential decay. Stay farce. Good stuff, good things. Roll Tide.